Namaste students, welcome back again to the virtual class. Hope you all doing well at home. So with that we will continue today's lesson. Before that, in the past video you must have seen we have been discussing about the light chapter. In that, reflection of light and refraction we have seen. So in that I have introduced the refraction phenomena. We have taken a rectangular glass slab, how refraction takes place and what are the laws of refraction. So whenever we study about refraction, its phenomena must be understood. So refraction is a process by which light enters into one medium to another and the bending of light takes place. Dear students, you must know that light appears to travel in a straight path as long as the medium remains same. If the medium in which the light is traveling changes, then the change of propagation of light we can see, and this process we call it as refraction. So in the last episode we have seen about the refraction by a rectangular glass slab and refractive index, and some numerical problems also we have solved. In today's class we will be seeing about the refraction by spherical lens. Before going to know about lens, you should know the basic idea about the lens. Dear students, whenever we talk about lens, the first thing that comes to our mind is the spectacles. So most of you may be wearing these spectacles. So this spectacle is especially used when you have some defects in your eyes. In order to see the enlarged images of the things around you, we use spectacles. And some other places you must have seen in binoculars, camera, telescope. These are other substances where some of the glass piece is being used, and with that we used to see the distant object clearly. So how could we see with the help of a piece of glass we can able to see the distant object or the smaller objects enlarged? So very interesting things and facts we will discuss in today's session. Whenever you see the glass pieces which are there in your spectacles, telescopes, microscopes, all these are, if you touch and feel, then you will observe that they are not flat. Somewhere it has some bulged portion. So the glass pieces which are attached with your spectacles, the glasses which are there in microscope, telescope, all these are lenses. So now we should know what is actually a lens. Sometimes you must have observed a drop of water falls on any surface or on a printed letter. The printed letter appears to be raised. So that is also a type of lens. Now we should learn what is lens, and if you understand the meaning of lens and further phenomena or further terms that are associated with the lens, then we can easily proceed further to understand the remaining portions. Dear students, lens is a transparent material which contain two surfaces, bonded by two surfaces. At least one surface will be spherical in nature. Now look at the screen here. Here you will find that a glass, spherical glass we can see. If we cut the glass, then we can see two surfaces. In this you can see one surface is flat and another surface is bulged or spherical. So we can say that a lens is a part of a spherical surface or spherical object. The spherical object will be transparent. Now we will discuss more about spherical lenses. While learning about mirrors, we have studied that mirror is classified into two categories. One is convex mirror and another one is concave mirror. Likewise, spherical lens is also classified into two categories. One is known as concave lens and another one is convex lens. Now, how can we identify whether the transparent material or the lens is concave or convex? Now look at the screen. The first picture shows that convex lens, in which two surfaces you can see. Here both the surfaces are bulged outward. If you touch and try to feel the surface of the convex lens, then you will find that at the edges you will see thickness will be very low. At the center you can find that some sort of bulging outward. So likewise here you see the sphere, at the center the thickness is more, but at the edges you see it is very thin. Such a type of lens is known as convex lens. So whenever we see a convex lens, its edges will be thin and at the center you will see it is bulged out or the thickness will be more. So, the first picture shows that it is a convex lens. Here you see both the surfaces are curved or spherical in shape. Such a type of lens is known as double convex lens. But on the other side you see this is also an example of convex lens, but one surface is plane and other surface is spherical. Such a lens in which one surface is plane and other surface is spherical or curved is known as plano-convex lens. Got it, children? Now we see another image in which it is also a lens, but the curved surface, if you see, if you carefully observe this lens, then at the edges you will find the thickness is more, whereas at the center it is very thin. So the lens in which the outer surfaces are thick and at the middle if you find it thin, then such type of lens is known as concave lens. Here the first lens shows that two surfaces and both the surfaces are curved outward, and at the edges you can see the thickness is more, whereas at the middle it is very thin. Both the surfaces are like that. Here this lens is known as a double concave lens because both the surfaces are spherical and appears to be concave, so it is called double concave lens. Whereas on the other side you see a picture, it is also a concave lens, but one surface is plane and other surface is spherical, that is concave. Such type of lens is known as plano-concave lens. These are the four different categories of lens which we will study in class 10th. Now we see various terms associated with these lens. So dear students, very carefully you observe it, because if you can't understand, then you cannot move further and you cannot solve the numerical problems. As far as this chapter is concerned, many numerical problems are asked in the CBSE examination. So basically the terms associated with the concave and convex lens need to be understood. So dear students, whenever we talk about lens, here you see double convex lens. Whether it is a concave lens or convex lens, the surfaces are the part of sphere. For example, if both the surfaces are extended further, finally you will see a sphere. So from this we can say that each surfaces of a concave or convex lens is a part of sphere. So when you extend it, we will get two spheres, and the center of the sphere is known as center of curvature. In both double convex and double concave lens, you will find two centers. These center points are called center of curvatures, as you can see here. So in double convex lens we will find two center of curvature. Likewise on the other side you see double concave lens, there also we will find two center of curvature. The imaginary line passing through the two centers of curvature is known as principal axis. So here it is the principal axis and there it is the principal axis. If you look at the double convex lens, the center point, this center point is known as optical center. So on other side also, so the center of the lens is known as optical center. Now we learn another new term. Here look at the picture. So this is the portion where light strikes over and refraction takes place, right? So the area, this portion is known as diameter. The diameter of the surface where the light ray gets refracted is known as aperture. As far as class 10th is concerned, our aperture will be very less than its diameter. So we will take lens with a small aperture. Dear students, you may be having an experience of burning paper with a magnifying glass, or even you can use your spectacles also. When light rays fall on the surface of the magnifying glass, then all the light rays which are coming from the distant object sun, all the light rays are converges to a point and we will see a bright spot. all the light rays are converged to a point, making it intense bright spot. This is known as focus. So whenever a convex lens is taken, in case of double convex lens, when the light rays parallel to the convex lens, then you will find after refraction all the light rays converges to a point. All the light rays are converged at a point. The point where all the light rays are converged is known as focus. And this converged point will appear on the principal axis, so it is called principal focus. Since the convex lens converges all the light rays to a point towards the principal axis, so convex lens is also known as converging lens. Whereas if you take concave lens, the light rays which are parallel to the principal axis, after refraction what happens? All the light rays appears to diverge from the principal focus. So the concave lens is also known as diverging lens. So the difference between concave and convex lens can be understood in terms of refraction, and after refraction convex lens converges the light, whereas concave lens diverges the light. Now look at the screen over here. The light rays which are coming from this side, when it strikes over the surface of convex lens, double convex lens, after refraction you can see that the light rays are converging towards the focus. Right, principal axis, the point where all the light rays are focused at principal axis, we call it as principal focus. Likewise, if we pass the light from that side, then we can see that after refraction all the light rays converges to a point on the left hand side towards the principal axis. So this point is also known as principal focus, or focus we can say. So a double convex lens will have two foci. The plural form of focus is foci. So likewise, in double concave lens also, two surfaces are there, in both the direction the light can refract. So double concave lens will also have double foci. So whenever we talk about double convex or double concave lens, there must have two foci. Dear students, look at the picture here. It is a double convex lens. If you extend it, this is the center of curvature, and the optical center is the edge of the spherical part, right? So we know that the center, the distance from the center up to the edge is known as radius. So we can say that the distance between the center of curvature and the optical center is also known as radius of curvature, and this radius of curvature is twice the focal length. So an expression we can write here, 2f is equal to r. That means radius of curvature is twice the length of focus or focal length. So these are the important terms which we must know. So whenever we talk about spherical lens, principal axis you should know, aperture you should know, optical center you should know, center of curvature, focal length, optical center, focus, double focus. All these concepts are very important, as these will help you to understand the image formation, how an image is obtained in a spherical lens. Now we see how image is obtained in a spherical lens. As we know that spherical lenses are two, convex and concave lens. Now we will discuss how image is formed. Before understand about the image formation, we should know the rules for forming image. As you know that in the mirror we have studied that in order to get an image, in order to obtain an image, at least two reflected rays must intersect with each other. The point of intersection towards the principal axis will give you the image. Likewise, here we are talking about refraction, right? Here, when the light rays are getting refracted, after refraction, the refracted, at least two refracted rays must intersect with each other. The place where the two refracted rays get intersected, the point of intersection towards the principal axis will give you the image. And as far as the image is concerned, We know that image can be classified into two categories. One is real image and another one is virtual image. Real image is a type of image which can be obtained on a screen, as we have already learnt in mirror while learning mirror. When we learnt about the nature of image in case of mirror, we have seen that the real image found to be obtained on the left hand side of the mirror, whereas the virtual image is formed on the right hand side of the mirror. Here the case is just reverse, which means the image which is formed on the right hand side of the lens is known as real image, whereas the image which is formed on the left hand side of the lens is known as virtual image. And erect, another nature of image is erect and inverted. The image which is formed above the principal axis is known as erect. The image which is formed below the principal axis is known as inverted. Now we will learn what are the rules which will help us to form image. The first rule, what it says is, the light rays which are parallel to the principal axis, after refraction, it passes through the principal focus. So as you can see on the screen, the light rays which are parallel to the principal axis, after refraction you can see that it is passing through the principal focus. This is the first rule. Second rule, the incident ray or the light ray which goes through the focus, after refraction you can see that the light rays are going parallel to the principal axis. That means these two rules are vice versa, we can say. If it goes parallel to the principal axis, then it will go towards the principal focus. If it passes through the principal focus, then after refraction, very well, it goes parallel to the principal axis. The third one is the light rays which are pointing towards the optical center. It does not show any deviation. Without deviation, it goes straight. As in case of mirrors, we have seen that the light rays which are going towards the center of curvature, it appears to come back in its same path. Likewise here, optical center, the light rays which passes towards the optical center, then without showing any deviation, it goes straight, it follows the straight path. So these are the three important rules. By using these three rules, we try to find how image is obtained on convex and concave lens. Now we didn't see the rule for concave lens, right? Now we will see how the rule is applicable for concave lens too. The rules which behaved for the convex lens, in the same way in concave lens also the same thing will happen. Now look at here, the light rays which are parallel to the principal axis, it appears to diverge from the principal focus. As we know that concave lens is a diverging lens, it will not converge the light rays which passes into it. The light rays which are parallel to the principal axis, as you can see on the screen, it appears to diverge from a place. When you extend it, then you will find that it will touch at the focus. Now we see the second rule. The light rays which are pointed towards the focus, then you can see that the light rays, these are diverging, it goes parallel to the principal axis after refraction. And the third rule, the light rays which are pointed towards the optical center, after refraction it won't show any deviation, the same way what we have seen in convex lens. So with these three rules we try to find how image is obtained on concave as well as in convex lens. Firstly, we will see how image is obtained on a convex lens. Later we will see how image is obtained on a concave lens. As far as image formation on convex lens is concerned, some tricks are there. If you follow those tricks, then it will be very easy how the image is formed. Whenever we see image formation on convex lens, there are 6 different positions where objects can be kept. And as we have already seen in case of mirror, object is always kept at the left hand side of the mirror. Similarly, here also object is always kept at the left hand side of the lens. As far as convex lens is concerned, here we will find 6 different places or positions where objects can be kept. On keeping objects at different positions, the image will be formed at different positions. And by using some easy tricks, you can easily identify where will be the image formation if the object is kept at certain place. Now, we will see one by one. If the object is kept at infinity, then the image formed will be at focus. As we have seen, the sun rays, when falls on a magnifying glass, all the light rays focuses on a particular point. So, point source we will get, right? So, whenever an object is kept at infinity, the image formed will be at focus. Now, the second position will be, the object can be kept away from the double focus or center of curvature. If the object is kept away from the center of curvature, then the image will be formed at the right hand side between the focus and double focus, right? And the image formed will be inverted and real. That means image will be formed at the right hand side below the principal axis. If any image is formed below the principal axis, we know that it is inverted, and image is formed on the right hand side means it indicates that it is a real image. Now, vice versa we will see. If the object is kept between the focus and center of curvature, on the other side the image will be formed at the away from the center of curvature on the other side. Here too the image formed will be inverted and real image. Now we see another position. If the object is kept exactly at center of curvature or double focus, then where will be the image formed? And what will be the nature of the image? If the object is kept exactly at double focus, then the image will be formed at the right hand side, which means real image, below the principal axis, which means inverted, and exactly at double focus or center of curvature. Now, if the object is kept exactly at the focus, then it's vice versa we have already seen. If we keep the object at infinity, then image will be formed at the focus. If object is kept at the focus, then the image formed will be at infinity. Image formed will be real. That means on the right hand side it will be formed, but at infinity. Now, the last sixth position, if the object is kept between the optical center and focus, then where will be the image formation? Here, when we keep object between the focus and the optical center, then image will be formed in front of the or left hand side of the convex lens, which shows that in other cases we have seen, all other cases we have seen image was found to be formed at the right hand side, whereas if we keep object between the focus and optical center, then image will be formed at the left hand side. That means on the same side where the object is kept, which shows that the image is virtual, and the image will be formed above the principal axis, which shows that it is erect. So these are the 6 different positions. What are those positions? First one is image can be kept at infinity, away from center of curvature, exactly at double focus or center of curvature, between center of curvature and focus. Fifth one, exactly at the focus, and the sixth one is between the focus and optical point. In all other cases, that means all other 5 positions, the image formed will be real and inverted, but at one position it forms virtual image and an enlarged erect image, that is when the object is kept between the focus and the optical center. So this way image is formed. We have already discussed that in order to form image, at least 2 refracted rays must get intersect. So how it is we will see. If the object is kept away from center of curvature, one example I will show you. Rest all examples you practice at home. In case of any queries, in case of any doubt, you can convey us through SMS and other modes. Now we keep the object away from center of curvature and we try to find where the image will be formed. Now see here, the light rays which are parallel to the principal axis, we know that after refraction it passes through the focus, right? So one rule we have used. Now we can use the second rule. What is that second rule? Second rule is when the light rays goes through the focus, then after refraction we know that it goes parallel to the principal axis, right? So after refraction we can see here two refracted rays are getting intersected at a point. From that point we have to connect it towards the principal axis. While doing so we get an image. So the point of intersection is the image formation. So this way image can be formed. Here we can use any of the two rules. No need to use all the three rules, right? Even if you use three rules, all the refracted rays will be intersected at one point only. This you can try at your home. So this way image is formed. So here you can see that the image is formed between the center of curvature and the focus, right? This is what we have been discussing earlier. So this way image is formed on a convex lens. So on other positions you just try at your home. Dear students, I believe you understood today's class and you found it useful. With this, I would like to conclude today's session. Before that, I would like to give some easy home assignments which you can practice at home. So here is your home assignment. Hope you will find all these home assignments easy. So that's all in today's session. In the next session, we will be seeing some important numerical problems which are very often asked in the CBSE examinations. Till then, keep learning, take good care of yourself. Bye.